notes, last set of notes for tonight, last bit. So we're going to do a full page of notes. It's really just because I write big, not because it's actually that much notes. And then I'll show you your examples. And what I expect for tomorrow is not only for factoring by grouping and its practice problems to be completed, but these notes and these practice problems actually be written down. You do not have to do these practice problems at home unless you want to give them a try. We will do them fully in class tomorrow. Okay, so this is called the zero product property, and it's very important. And what it is starting to get us to do is actually solve quadratics. So we've factored them, now it's time to solve them. So solving quadratics by factoring. Okay, so this is really important. Alright, so we're on page 47. We're going to put 3-6 because that's the date we actually put the notes into our notebook, or we should be putting our notes into our notebook, I guess I should say. Alright, now we've factored quadratics and we've figured out how to factor them and we've worked on that. But we got to start learning how to what actually happens when we solve quadratics, and this turns into being able to graph them and understand what the zeros of these problems mean. So solving quadratics by factoring. Now, what we do and what we use to do this is called the zero product property. Okay. The zero product property basically states if A times B is equal to 0, then A is equal to 0 or B is equal to 0. Okay? So A and B represent our factors. So we've factored a quadratic and we've gotten this parentheses times this parentheses, but now we're setting them equal to 0. Then A is equal to 0 or B is equal to 0. So in this type of problem, instead of just having y is equal to x squared plus 2x plus 3, we're going to get x squared plus 2x plus 3 is equal to 0. Okay, so we're changing our functions around. Alright. A couple things we need to know about the zero product property. The zero product property requires the equation or in our case function to be set to 0. Okay. Rearranging may be necessary. You're going to want a highlighter. You're going to want to make some notes with your highlighter, so grab a nice yellow highlighter here. And I'm going to highlight requires the equation to be set equal to 0. That's super, super important. We really need to make sure that we understand that. Like, I can't overstress to you how important that statement is. Okay, so now we're going to be working with things set to 0. Okay. Second thing about our zero product property is that before applying the property, the equation our function must be fully factored. Okay, so what's really important and key out of this statement, highlighters, okay, is that before applying it, okay, we have to be fully factored, okay? It has to be fully factored. Like, super important. We can't just half that job, okay? We got to make sure it's fully factored. All right, my little peoples, our examples. We're going to do two. One that we have to rearrange and one we do not. All right, so here's our examples. X squared plus, oops, I'm sorry, not plus, subtract 9x plus 18 is equal to 0. Okay. Then we're going to go ahead and just write our second example, just so we have it out of the way. 2x squared plus 6x is equal to negative 4. Okay. So one is already set equal to 0, the other one is not set equal to negative 4, and we're going to have to rearrange that. Alright, so since we're set equal to 0 already, okay, looking at this problem, it's in standard form. So here's your A, here's your B, here's your C. We should already know. Let me go ahead and zoom in a little bit. Okay. We factor it like we factor everything right now with an X puzzle. So we're going to get our lovely little X puzzle here. C is at the top, so we get a positive 18. B is at the bottom, so we get a negative 9. Okay. And when we're factoring, we factor 18. So we now know the factors of 18. So if I look at 18, I get 1 and 18, 2 and 9, and 3 and 6. Okay. So looking at these factors, okay, so we have our factors here, 1 and 18, 2 and 9, 3 and 6. I've got to get to 9. 1 and 18 is never going to get to 9 no matter what. 2 and 9, no matter what, but 3 and 6 will. So these two aren't going to work. But looking at this problem, B is negative, C is positive. So we talked about when that happens. If B is negative but C is positive, that means that both factors have to be negative. Okay. So we did our X puzzle, right? We solved, we got our factors. So we have x minus 3 times x minus 6, just like we've been working, but now it's set equal to 0. And this is where our zero product property comes. We need to figure out what x can be. What is the solution to this quadratic? So, zero product property. If a times b is equal to 0, a times b is equal to 0, then a can be set equal to 0, or b equal to 0. So go back down here, and what we do is we literally say x minus 3 is equal to 0, x minus 6 is equal to 0. And we're going to solve for x. Okay, we want to know where, if I'm graphing this, where is it crossing over the x-axis? How is it interacting with the x-axis? So we should be able to solve one-step equations. We're just going to add 3 to both sides, nice and easy. Add 6 to both sides, nice and easy. A cancel, and we should see that we have x is equal to positive 3 and x is equal to 6. Okay. Now, what does that mean for you? That means that at these 2 points, when x is 3 and x is equal to x is 6, the y is going to be 0. So that's where, if we were to graph this, we would have a y-intercept at 6 and a y-intercept at 3. And we'll get to graphing soon. Okay, so we've solved this by using the zero product property. Okay. Now, solving this one. Before we can do anything, we've got to set this problem to 0. How do we set it to 0? We're going to take this 4 and we are going to move it. Okay? How do we move it? Well, if it's a negative 4 and I want to move it, I have to add it. So I'm going to add 4 to both sides. Now, if you notice, on this left-hand side, I did not put 4 directly below any of the other terms. Okay? That's because I can't combine the terms. I just need to move it over. On this side, though, these two are going to cancel out. Okay? Now, we want this in standard form. So we're going to still start with our 2x squared plus 6x, and now comes this plus 4. And it's set equal to 0. Okay, so we just move the 4 from the right-hand side to the left-hand side. And again, we have A, B, C. But like I've always said, we need to check to see if we have a greatest common factor, because right now, this A is greater than 1, which means I'm going to have to do slide divide bottoms up if they don't have anything in common. Well, when I look, they have a 2 in common, so I'm going to pull a 2 out. Okay, so that means everything is getting divided by 2. Well, 2 divided by 2 is 1, so we just left with an x squared, plus 6 divided by 2, that's 3x, plus 4 divided by 2, that's a 2. And it's still equal to 0. So that little 2 right here is going to follow us all the way down until we're done. Again, this is A, B, and C. I need my X puzzle. I have a positive 2 at the top and a positive 3 at the bottom. If I'm looking at the factors of 2, so I'll just do it over here, we know what they are. 1 and 2. That's it. Okay. Can 1 plus 2 equals 3? Of course it can. So we get 1 and 2. Both C and B are positive, so that makes both factors positive. So I'm going to get, I still have this little 2 out front here, so 2 still out front, and I have x plus 1 times x plus 2, and the whole thing is set equal to 0. Okay. Now, we factored it. It's fully factored. There's nothing else we can do. When we're solving for zeros, this 2 does not affect our zeros. What it affects will be our graph when we get to graphing. But when we're just looking for zeros or solutions, roots, x-intercepts, this 2 does not affect that. So that kind of just almost disappears when you do this next step. It's still there in our problem, but it doesn't affect our zeros. So what we do is we say x plus 1 is equal to 0, x plus 2 is equal to 0. And we solve. So subtract 1, it's always the opposite of what you see. So we subtract 1. Subtract 2, always the inverse operation. And we have x is equal to negative 1, and x is equal to negative 2. These are the solutions to our problem. Okay, solution. Okay, so what we're going to do is we're going to write a final note. We're going to put in a color that stands out. I don't know what color that's going to be. Let's go with this. Let's go with this bright blue. We haven't used that since the very top. Okay, so solution equals root, which equals a 0, which equals x-intercept. Okay. All of these mean the same thing. I could call it a solution, I could call it a root, I could call it zeros or x-intercepts. They all mean this process right here. Okay, so these are your notes for using the zero product property or solving quadratics by factoring. And here are your example problems. Alright, so here's solving by factoring practice. These are our practice problems we're going to use. So, problem number 1, x squared plus 4x minus 12 is equal to 0. Problem 2, x squared minus 4x plus 21 is equal to 0. X squared minus 3x minus 9 is equal to 0. X squared minus 16 is equal to 0. Okay, 4 problems. Okay. So you need to find their root, their zeros, their solutions, their x-intercepts, everything that we did on the other page. You can attempt them tonight, or if you're not so sure because we didn't talk about these notes today, go ahead, just get them copied down, leave enough gap to leave your work, to show your work tomorrow, and we will go over these tomorrow in class. We will go over these tomorrow in class, and we will also go over your grouping practice problems in class also. Alright, so thank you. Have a great evening. Make sure you get all this down. I'll flip it back over. Last final picture. Take your time through the notes. Pause it. Rewind it. Go back. Make sure you understand. Do the examples with me. Try to figure out the second one. Maybe go ahead and pause it after the first one and try to figure out the second one. Go ahead and do these. Alright? Have a good evening, guys.